Good evening, and on behalf of my team, I'd like to welcome to our project, Transit-Oriented Development in Bridgeport, Connecticut, specific to implementing distributed energy generation and green infrastructure. Now, as far as our agenda, we're going to speak to the background and the project scope of our project, and then we'll speak to the methodology of how we came about our recommendations. Next, we'll speak about distributed energy generation, or DNG in general, and the challenges and recommendations we came to for that. And it's the same for green infrastructure. Excuse me. Whew. Okay, I was running. But next, we'll speak to the funding and governance for TOD, or transit-oriented development, our project challenges, and the intended use for our report. Specifically, our client, RPA, or Regional Plan Association, is a bridge to New York, Connecticut sustainable communities. Specifically, the Department of Transportation, the Department of Housing and Urban Development, and the EPA fund the sustainable communities, and pretty much this program explores and fosters sustainable, livable communities. It fosters sustainable and livable communities. Specifically, out of the 17 communities, we've chosen to focus on Bridgeport in Connecticut, namely the East Bridgeport Development Corridor. Our project scope specifically speaks to looking at ways to recommend, implement distributed energy generation and green infrastructure. Now, distributed energy generation is a centralized energy production. The strategies that we chose for our project were solar photovoltaic, microturbine, fuel cell, and combined heat and power. Green infrastructure, or GI, refers to strategies to handling stormwater at the source before it enters into the sewer system. Our strategies for this were vegetated swells, permeable pavements, green roofs, and rain harvesting. Now, just to give a little bit of background on Bridgeport itself, our project is specifically oriented around the land for a proposed train station, or the proposed East Barnum train station to be exact. Now, I know that it looks like a huge swath of land, but in comparison to Bridgeport County itself, it's only approximately 7% of the land use, or the land area rather. The methodology for coming about the recommendations for this meant that we had to figure out specific strategies for Bridgeport itself. Next, we had to look at the challenges associated with implementing these strategies, and those were specifically environmental justice, funding, and governance. Now, our recommendations, or our promising strategies, spoke to, or pretty much provide a future baseline for our client to look to after the report. For distributed energy generation, as I said before, our strategies were solar photovoltaic, microturbine, fuel cell, and combined heat and power. Now, a common thing among all of these strategies, although beneficial, were that they had high upfront capital costs. But the thing was that these kind of costs can be offsetted through funding programs such as the Connecticut Clean Energy, and there are others as well. In keeping with the theme for funding, and our analysis, although we saw that there were a variety or an array of funding opportunities or grants and incentives that people can partake of, we found that it was very difficult to navigate into these. And it was our main recommendation that we appoint an energy liaison officer to kind of facilitate or assist the residents and commercial developers who wanted to receive funding for these projects. Another benefit for implementing DEG is that with the new demand for building on the East Bridgeport Development Corridor, there'll be an increased load on the grid itself. So by implementing distributed energy generation, we can offset the demand for that new load. In green infrastructure, our strategies were permeable pavements, vegetated swells, green roofs, and rain harvesting. And the benefit for all these strategies was that they reduced the amount of stormwater runoff that entered into the combined sewer system. Ultimately, it reduced the number of CSO occurrences that happened in the area, or pretty much it reduced the amount of untreated water discharge that flowed into the harbor. Now, in addition to stormwater management, another benefit to green infrastructure is that it reduces water and air pollution. For our recommendations, using other cities as a baseline, it became apparent that small targeted projects didn't achieve a great benefit in the long run. But because we have a large swath of land spanning almost some 700 acres, we found it appropriate to implement and perform a robust monitoring system and program to determine the effectiveness of green infrastructure strategies in Bridgeport. Now that we've established this information and that it's important to study, our main point was to make a case to the Connecticut Clean Water Fund that they secure funds in the long term for these types of projects. Challenges, and we encountered many. But the key challenges that we found for this project and for both projects is that we could not find Bridgeport-specific data, or it was very difficult to find this data. So it was a major recommendation as well to establish a baseline for, in DEG, establishing a baseline for energy consumption, and in green infrastructure, establishing a baseline for collecting stormwater data. Our report use. Pretty much, our report provides a background knowledge of the benefits and the benefits of these recommended strategies. And our client consists of a large number of stakeholders. And this report can pretty much tell them about the different opportunities available for looking at these promising strategies. So pretty much that's how we oriented our project. And that's it.